In this video, we're going to look at the solution to this worksheet, quadratic functions transformations. And on this sheet, the goal is to learn more about the graph of f at x equals x squared, also y equals x squared. Okay, so sometimes we'll see this in function notation, and sometimes we'll see this in just notation we're used to, the y equals. If you recall from grade 10, when we're graphing these quadratic functions, the equation always has some sort of squared in it, x squared, or the resultant, when it's expanded, we end up with an x squared. The graph itself is always this parabola shape or parabolic in shape. When we fill in this table of values, you'll notice that we can see the vertex in the center here, and then on either side, we have those repeated values, resulting in vertex in the center and symmetry about that vertex. Along this line of symmetry, we end up with points that are symmetrical on either side of that line of symmetry. You'll also notice when we have our regular graph of y equals x squared, vertex is at 0, 0, and their points follow a pattern from the vertex over 1 and up 1, over 2 and up 4 units. And we're going to look at the pattern and see if it changes at all through our investigations. The first part of this is investigating when we add or subtract a number after we square our x or square each of our values. You'll notice that in Desmos, when you did this, you'll see that this pattern, the parabolas seem to be shifting up and down. You'll also notice, if you actually draw the points of each, that the pattern in the original x squared actually stays the same with all of these. We have our vertex, and then over 1 and up 1 from the vertex is the next dot. Over 2 squares from the vertex and up 4, we get our next point on each of these graphs, and that pattern is the same over 1 and up 1, over 2 and up 4. So it's the exact same shape, we've just translated or shifted the whole graph up and down. So on here, when it asks us describe the effect, the formal language is a vertical translation. And you'll notice that in general, we'll say y equals x squared plus k, or f at x equals x squared plus k. And that value of k, if k is greater than 0, then it was translated up. And if it was less than 0, it was translated down. So up for greater than 0 and down for less than 0. Okay. Part B now is investigating what if we add or subtract a number to the x before we square. So because these are numbers in the brackets, BEDMAS tells us we're going to have to do that, subtract 2, and then take the answer and square it. Add 3, take the answer and square it. Add 5, take the answer and square it. And what happens when you graph these is you'll notice instead of a translation vertically, now we have a horizontal translation. So this is left and right. Now, when you look at this general form, it says y equals x minus h all squared. Okay. You'll notice that it says minus. So if I have a subtract 2, my h value, my h is actually positive 2, since the original formula has a negative sign in it. So when h is greater than 0, we actually shifted the graph to the right, but in the equation is negative. So if the equation is negative, it is to the right, the opposite of what you would have thought. So 2 squares to the right. Plus 3, we shifted the parabola backwards, 3 squares to the left. Similarly to the other one, you'll notice the shape didn't change. It's the exact same pattern. Over 1, up 1, over 2, up 4. So the pattern stays the same. We're just shifting the whole thing left and right when there's something in the brackets. Our part C here is investigating what if we multiply by a constant. So in the front here, I'm multiplying by 4. I'm multiplying by 1/2. I'm multiplying by 1/4. Again, because of BEDMAS, I'm going to do my squaring and take that answer and times it by 4, times it by 1/2. And what happens, you'll notice that the graph got steeper or wider. It looks like taller or wider. Okay? What we're going to use, though, instead of thinking about it getting wider left and right, we're thinking about stretching it taller or compressing it shorter. So we're going to call these a vertical. So if that A value, that number in front, A is greater than 1, then it is a vertical stretch. Now, if A was a value between 0 and 1, so I'm going to use like my domain and range notation. If A is between 0 and 1, okay, so it doesn't equal 0, it doesn't equal 1, but it's between 0 and 1, then we have a vertical compression. So I'm compressing it vertically, which makes it squish down, and visually it looks wider. Okay, so this is a vertical stretch or compression. And you'll notice with this one, there's no moving left and right or up and down. It just gets taller, so the shape is changing. This is changing the shape. Our part D here is when we have, what happens when we have a negative in front. Hopefully you remembered this one from grade 10. Whenever it starts with a negative, my graph opens down. So it opens down. But the formal term we're going to use is a reflection over the x-axis. Okay, so the whole parabola opens down, but we're going to have to remember the formal term. It's a reflection over the x-axis. Okay. Now, I'm going to skip down to this final part, which is the combination of transformations where we're putting things together. So you'll notice that now, instead of just one of these movements, we're doing a bunch of things at the same time. So when we look at this, where we have a +3 at the end, that's where we had those vertical movements up and down. So I'm going to take my normal vertex, which is at 0, 0. I'm going to draw my parabola here. The base parabola, which is y equals x squared. And you'll notice with this one, it says, let's move the whole thing up 3. Change my color here. I'm going to move or translate the whole thing up 3. So my vertex is going to move up 1, 2, 3. But then when I look at this first number, it has a -2 in the brackets. And remember, in the brackets is left and right, opposite of what you think. So I'm actually then going to move my vertex to the right 2. So now what I've done, instead of having my vertex at 0, 0, my vertex is now ending up at +2 and +3. So I've actually kind of moved the vertex. My shape doesn't change because there's no number in front here. There's no A value. So in other words, the number there, if nothing's written, it just means it's a 1. There is no stretching or compressing. So my pattern is going to be the same. So my pattern is over 1, up 1, over 2, up 4, over 3, up 9. So from this vertex that I now have at 2, an x of 2 and a y of 3, I'm going to go over 1 and up 1. And there's my first dot on my parabola. I'm going to go back to the vertex, over 2 and up 4. Second dot, then I'm going to write my matches on the other side. Okay, there's my parabola, and I'm done. In part B, my vertex, the left and right is my x value, opposite of what you think. So now it's -1, and -4 is the y value because I've shifted from the regular vertex at 0, 0. I've shifted down 4 and backwards 1. There's my new vertex at -4, or -1, -4. Pattern is the same, over 1, up 1, over 2, up 4. And on the opposite side of my axis of symmetry, I'm going to have that match. Remember, axis of symmetry down the center here. I'm going to have my matching points. Okay. Now I've only put on 5 points. This one I have space for the other. I could have gone over 1, 2, 3 and up 1, 2, 3, 4, 5, 6, 7, 8, 9. I could have another point up there if I wanted to with its match over here, and I would have continued this parabola up past that point. Okay. The other type of transformation is, what if I have another number in the very, very front? So this one, this number in the front, is stretching everything. So my vertex, I'm going to get the same way as before. My vertex come from these two numbers, that 4 and the -1. So -4 and -1. I move the vertex from 0, 0. I'm going to move it down 1. And I'm going to move it backwards 4. 1, 2, 3, 4. There's my new vertex. Now the 2 in the front is changing my pattern. It's going to have this stretching thing. So all my pattern is going to be stretched taller. So I'm going to move same thing over 1, over 2, over 3. But now my ups are going to be different. They're going to be stretched by 2 times taller. So instead of over 1, up 1, I'm going to go over 1, up 2. And over 2, up 8, or 4 times 2. 9 times 2, or 18. I'm definitely not going to be able to fit this one on. So from my new vertex, I'm going over 1 and up 1, 2 points with its match over there. Over 2 and up 1, 2, 3, 4, 5, 6, 7, 8. It just fits. It just fits. So everything is that much taller than before. Way taller than before. Okay. Last one here, just as an example, I have my vertex. I'm moving my vertex up 1 and to the right 3. So my new vertex is going to be over here. There's my vertex. It's going to be at +3 and +1 is my vertex. Same stretching as before, except now I have this negative sign in front. So similar to the pattern in part C, the over 1 up 2, over 2 up 8, over 3 up 18. Now I'm going to do that whole thing, except I'm going down instead of up because of that negative. It opens down. And then over 2, down 2, 4, 6, 8, and 8. And there's my parabola shape. Okay. So final step, this is my stretching or compressing. Also is reflecting if it's negative. And the last 2 parts here, my H is right, left, backwards from what you would think, and the K is the up-down movement. The vertex is always the H and the K. That's all for now.